Okay guys, so now that we have all of those beautiful double angles, we are going to use them to manipulate them to derive more formulas, okay? So we're going to do power reducing and half angle from your double. So we're just going to pick one of them, because if we can do one, we can do all. So let's do cosine of the double. Well, as you know already, the cosine of double has many. So we're just going to pick this one. The first that we're going to try to derive is the power reducing formula. This is not so much for pre-calc, but it's for later in calculus. So that way it's easier for us to do derivatives, okay? So power reducing formula, our goal is, guys, for power reducing, it's just really to isolate sine square, okay? It's just that easy. So we're going to move the 1 over. So subtract 1 from both sides. So that will give us cosine of 2 theta minus 1 equals a negative 2 times sine square of theta. Then, as you can see, we are going to divide both sides by a negative 2. Then now, in math, or when we want to look pretty, we normally don't like negative numbers in the denominator. So we can multiply top and bottom by a negative 1. So with that, we now have sine square on the numerator is now a negative cosine of 2 theta, and then this is a positive 1 because we multiplied the entire numerator by negative 1. Now we do have a positive 2 on the bottom, but we don't like that negative in the front, guys. So typically we want to write it as 1 minus. We're going to swap the numerator around, okay? So this is the power reducing formula for sine square. Now, as you can see, we can take the other double angle of cosine, the one that contains just the cosine, and we can do the same thing to get cosine square, and we can do the same thing for tangent. So the power reducing formula, there are 3. So the first one, we're going to copy this down, okay? So sine square of theta equals 1 minus cosine of 2 theta all over 2. We also have, again, we could use the double angle of cosine that contains only the cosine square, and we can come up with the same thing. So cosine square of theta equals cosine of 2 theta plus 1 all over 2. Now the tangent is just simply sine square divided by cosine square, okay? So if we want to have tangent square identity, then it's going to be sine square divided by cosine square, which we're going to use this divided by that, okay? So if that divided by that, the 2's will cancel out. So we're going to have 1 minus cosine of 2 theta divided by cosine 2 theta plus 1, or 1 plus cosine of 2 theta, if that's how you want to look at it. So these are just identities, okay? Well, you guys know sine square is 1 minus cosine square. And then same thing with this, but now we just have others that we can use as well. So now that we have more to use, you can use whatever you want, whichever is easier for you. Now, how do we come up with the half angle? Well, the half angle is going to come from this guy over here, okay? As you can see here, I'm going to write it again. So sine square of theta is 1 minus cosine of 2 theta. I'm going to write it again because we need to go a little bit further to do half. We are going to now take a square root of both sides, okay? Because I want to solve with just sine. So square root and a square root. Then obviously that's going to give us a plus and minus on this side, okay? Okay, now all of that is under the radical, students, all of that on the right side. This is the manipulation, okay? What if we let every theta we see be an alpha divided by 2? If that's the case, then we are going to say, okay, well, sine, I see an alpha, I see a theta. I'm going to replace it with alpha divided by 2. So we're going to let theta equals some alpha divided by 2. Okay, so let's say theta is 30 degrees, then this will be 60 divided by 2. Okay, if theta is 45, then alpha will be 90 because 90 divided by 2. So every time we see a theta, we're going to substitute it with alpha divided by 2. Then this again is plus or minus. That doesn't go away. Big radical. 1 minus cosine. I see a 2. I see a theta, but now it gets alpha divided by 2 all over 2. This will now simplify down to that. So this allows us to write sine of alpha divided by 2 equals plus or minus big radical 1 minus, well, now we just have cosine of alpha divided by 2. Again, that 2 is under the radical. That's how we came up with the half angle. Can you see that this is half because it's alpha divided by 2? Exactly. So we can do the same exact thing if we use this power reducing for cosine and this for tangent. Okay? So let's write the half angle for sine down. So sine half angle alpha divided by 2, or you can use x divided by 2, or you can use theta divided by 2, it doesn't matter. The plus or minus must be there. Big radical now. So we're going to go 1 minus cosine of alpha all over 2. And we're going to write down the half for cosine. Students, the proof will go the same exact way. 1 plus now cosine of alpha all over 2. Don't forget, it's very important to write the plus or minus in the front. And then the tangent, I'm just going to do sine divided by cosine. So that means this divided by that. Okay? And then again, the 2 will cancel. So plus or minus big radical 1 plus cosine of alpha all over, oops, don't do that, minus 1 minus cosine of alpha over 1 plus. Okay, again, on the numerator is sine, so 1 minus. In your book, so if you look in your book, there are a few more identities for tangent of alpha over 2. So you can write that down if you want. Now the reason they have that is because if you think about it, I can take a square root of many things, right? So that's why. So look at the book again to see if you like the ones they have written in your book. But this one, the tangent, this one, it's easier for me because I don't have to memorize another formula.